We now discuss the solution of a problem from the section Real Analysis, and this question has appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the convergence of series of real numbers. This question is from the part B. It is a multiple choice question carrying 3 marks. The question ID is 704023. The given question is: consider the following infinite series. Series A, sigma n is equal to 1 to infinity sine of n pi by 2 by square root of n. Series B is given by sigma n is equal to 1 to infinity log of 1 plus 1 by n square. Which one of the following statements is true? We are given 4 options, and these options are related to the convergence of the series A and the convergence of the series B. The regular 4 options are given. Right. Let's now discuss the solution of the problem in detail. We first consider the series given by A, that is sigma n is equal to 1 to infinity sine n pi by 2 whole by root n. Call this as the sigma an, where an is sine of n pi by 2 whole by root n. Right. And if you look at this sine n pi by 2, as n is varying 1 to infinity, it takes the values 1, yes, it takes the value minus 1, it takes the value 0 also. So we'll break this sigma n is equal to 1 to infinity into 2 parts. That is, the first part is sine of the odd positive integer times pi by 2 by the square root of that odd plus sigma the even, that is sine of the even times pi by 2 by under the square root of even. So that is, the first part is sigma m is equal to 1 to infinity sine of 2m minus 1 times pi by 2 by square root of 2m minus 1. So as m is varying from 1 to infinity, 2m minus 1 pi by 2 will give you the odd multiples of pi by 2. The second part plus sigma m is equal to 1 to infinity sine of 2m times pi by 2 by under the square root of 2m. This will give you the even positive integer times pi by 2. Agreed. Now this will give you sigma m is equal to 1 to infinity sine of 2m minus 1 times pi by 2 by square root of 2m minus 1. And this series will give you 0. Why? Since sine of 2m times pi by 2 is sine of m pi, where as m is varying 1 to infinity, sine m pi will give you 0. So therefore this part is 0. So we are left with this one. So Now note that sine of 2m minus 1 pi by 2 will be 1 if m is odd and is equal to minus 1 if m is even. That means it will give rise to minus 1 to the power of m minus 1. I will explain this here in the snippet. Now, when m is equal to 1, sine pi by 2 is 1. When m is equal to 2, sine 3 pi by 2 is minus 1. When m is 3, it will give you 1. When m is 4, it will give you minus 1, and so on and so forth. That's what we said. Sine of 2m minus 1 times pi by 2 is 1 when m is odd, is minus 1 when m is even. Now, this is same as minus 1 to the power of m minus 1. Agreed. So, this will be equal to, sigma m is equal to 1 to infinity minus 1 to the power of m minus 1 by under the square root of 2m minus 1. Now, let us take it as sigma m is equal to 1 to infinity minus 1 to the power of m minus 1 bm, where bm is 1 by under the square root of 2m minus 1, and each term is positive for all m belongs to n. And what is this? This is an alternating series. This is an alternating series. And you can see this bm is equal to 1 by under the square root of 2m minus 1 is decreasing, monotonically decreasing. That is, the first condition is bm plus 1 less than bm for all m, and limit m tends to infinity of bm is 0. Two conditions of the Leibniz test are satisfied. So, by Leibniz theorem, sigma m is equal to 1 to infinity minus 1 to the power of m minus 1 into bm is convergent. But this is precisely sigma an. So, therefore, sigma n is equal to 1 to infinity an is equal to sigma n is equal to 1 to infinity sine of n pi by 2 by square root of n is convergent. That means the series given by A, thus the series given by A is convergent. Now, in the next slide, we will talk about the series B. And we have the series A is convergent. We have the series B given by sigma n is equal to 1 to infinity log of 1 plus 1 by n square. Agreed. Now, let's take this as an, sigma an, where an is log of 1 plus 1 by n square is greater than 0 for all n belongs to n. That means there is a series of positive terms. Agreed. Now, we consider the auxiliary series sigma n is equal to 1 to infinity bn, where bn is equal to 1 by n square greater than 0 for all n belongs to n. Now, the question is, how did we guess the auxiliary series as sigma bn, that is sigma 1 by n square? For that, the answer is, log of 1 plus 1 by n square, the expansion of logarithm is 1 by n square minus 1 by 2 into 1 by n square whole square plus 1 by 3 into 1 by n square whole cube minus so on and so forth. Take 1 by n square common. 1 by n square times 1 minus 1 by 2 into 1 by n square plus 1 by 3 into 1 by n square whole square minus so on and so forth. That's how we have made a guess of considering the auxiliary series as 1 by n square. That's the reason. So now we want to apply the limit comparison test. For that, we take limit n tends to infinity an by bn, that is limit n tends to infinity, an is log of 1 plus 1 by n square by 1 by n square. As n tends to infinity, this takes a 0 by 0 form, which is an indeterminate form, and we use L'Hopital's rule. That is equal to limit n tends to infinity. The derivative of the numerator is 1 by 1 plus 1 by n square. 1 by n square with respect to n is minus 2 by n cube. By derivative of 1 by n square with respect to n is minus 2 by n cube. The cancellation takes place, minus 2 by n cube minus 2 by n cube cancels. Limit n tends to infinity is 1, which is not 0 and is finite. So by limit comparison test, both the series behave alike. That is, the two series sigma an and sigma bn either both converge or both diverge. Now we consider sigma bn, and sigma bn is 1 by n square. This is of the type sigma bn is sigma 1 by n to the power of p. These are called p series. Here p is 2 greater than 1. When p greater than 1, the p series is convergent. So hence here sigma n is equal to 1 to bn is sigma n is equal to 1 to 1 by n square is convergent by p series test. Here p is equal to 2 greater than 1. Therefore, sigma an is also convergent. So thus the series B is convergent. So sigma A, the series A is convergent, which we have already seen. Now the series B is convergent. Thus both the series A and B are convergent. Let's look at our options and our answer. Both the series A and series B are convergent appears against option 3. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of this problem from the real analysis on the convergence of the series. It is definitely an easy and straightforward question of applying the tests of convergence. I am sure that you have understood the solution of this problem. If you like my videos, please register your liking by posting the like icon, that is the thumbs up icon in the channel. So I am sure that you like my videos. Please share with your friends and colleagues who are aspiring to clear this examination. If you have not already subscribed, please subscribe my channel and request all your friends, relatives who are giving this examination to subscribe this channel. I wish you all the best. Thank you.